Hey guys, welcome to Tech Tools YouTube channel. Today in this video, we are going to see what is inside the Deep Learning Toolbox in MATLAB Simulink. Let's start today's video. So this is the Simulink interface. So at first, we will go to this library browser, then this library icon. Click on here, and this is Deep Learning Toolbox. So here are four segments. First one is deep learning layers, then deep neural networks, then Python neural networks, then shallow neural networks. So at first, what is deep learning toolbox is used for? The deep learning toolbox in Simulink is a set of tools from MATLAB that lets you design, deploy deep learning models within Simulink models. It is commonly used for applications such as image creation, speech recognition, autonomous driving, predictive maintenance, and signal processing and control systems. With the Deep Learning Toolbox in Simulink, you can import trained neural networks such as CNNs, LSTMs, or other deep learning models. Add deep learning blocks to your Simulink model. Simulink system that use AI together with sensors, controllers, and physical models. So let us see what is inside these blocks. So first one is deep learning layers. So double click on it. So here are several layers like activation layers, combination layers, convolution and fully connected layers, input layer normalizations, normalization layers, pooling layers, sequence layers, and utility layers. So inside these layers there are several layers also. So double click on activation layer and you can see the layers inside activation layer. So this one is clipped ReLU layer, GeLU layer, leaky ReLU layer, ReLU layer, sigmoid layer, softmax layer. Then we have combination layers. So here in combination layer we have addition layer, concatenation layer, depth concatenation layer, multiplication layer. Then we have convolution and fully connected layer. So here we have convolution 1D layer, convolution 2D layer, convolution 3D layer, and fully connected layer. Then we have input layer normalizations. So here we have rescale symmetric 1D, rescale symmetric 2D, rescale symmetric 3D, rescale 0 1 1D, rescale 0 1 2D, rescale 0 1 3D, 0 center 1D, 0 center 2D, 0 center 3D, Z score 1D, Z score 2D, and Z score 3D. Then we have normalization layer. So here we have base normalization layer, layer normalization layer. Then we have pooling layers. In pooling layers, the blocks are average pooling 1D layer, average pooling 2D layer, average pooling 3D layer, global average pooling 1D layer, global average pooling 2D layer, global average pooling 3D layer, global max pooling 1D layer, global max pooling 2D layer, global max pooling 3D layer, max pooling 1D layer, max pooling 2D layer, and max pooling 3D layer. Then we have sequence layers. In sequence layers, we have flatten layer, LSTM layer, LSTM projected layer. Then we have utility layers. Here we have dropout layer. Then we have deep neural networks. In deep neural networks, we have image classifier, predict, stateful classify, and stateful predict. Then we have Python neural networks. In Python neural networks, we have custom Python model predict, ONNX model predict, PyTorch model predict, and TensorFlow model predict. Then we have shallow neural networks. In shallow neural networks, we have control system, net input functions, processing functions, transfer functions, and wait functions. So inside the control system blocks, we have model reference controller, NARMA, L2 controller, NN predictive layer, NN predictive controller, X, Y2 graph. Then we have net input functions. In net input functions, we have net prod, net sum. Then we have processing functions. In processing function, we have fixed unknowns, reverse, LVQ outputs, LVQ outputs reverse, min max, map min max reverse, map td reverse, process PCA reverse, remove remove constant rows reverse, remove rows reverse. Then we have transfer functions. In transfer function, we have these transfer functions. Comp Iliad to sig, Iliad to sig, Iliad to sig, Iliad sig, hard limbs, log sig, and many more. Then we have wait functions. In wait function, we have dist, nor prod. So that's it for today's video. Thanks for joining us.